My name is Mr. Schweitzer, and I'm going to give you a little preview into our gravimetric analysis lab. Now, gravimetric analysis, the word gravimetric means gravity. There's a filtration here where we used to always filter things via gravity, just in a funnel with a filter paper. We're going to use a different method for funneling that will go a little quicker, but the name still holds where we're going to be filtering, and that gravic means gravity filtration. The general idea of this lab is that we're going to convert an unknown soluble compound, something that's dissolved in water, and we're going to, via chemical reactions, convert this into a known compound that's insoluble, and then we will filter out this compound because it is in fact insoluble. Okay. Now, essentially, we have this unknown compound that's floating in water, and we have a way of chemically sort of, I might say, tag it and get it to fall out. So in this case, we have, for this lab, we have some known copper X. This compound contains copper. I don't know what it is. It could be copper sulfate, it could be copper nitrate, it could be copper chloride, it could be copper iodide, it could be some copper compound. Now, what we're going to do is take this unknown soluble compound in its nice blue color, dissolve it in water, and then use a base to convert this unknown compound of copper to copper hydroxide. This is a dark blue slushy chemical, but is not very easily handled and is kind of sensitive. It oxidizes easily. So we'll just go ahead and let it oxidize with some heat to speed it up. If you get to this point in the lab and you're running out of time, it will oxidize overnight if you just leave it sit on its own. Heat will be a way of speeding it up to form copper oxide. Now, as far as conservation of mass is concerned, our overall goal for this lab is to identify the unknown compound. Okay, so conservation of mass is important here. What we're going to use to identify this compound is the percentage mass copper of this unknown compound. So to figure that out, we need two pieces of information. We need to know the mass of the copper, okay, and we need to know the total mass of the sample. This you can get simply from the initial mass of your sample. You weigh it out. You should have that be the first thing you write down when you mass out your sample. This you should have easily. Now, in that sample contains copper. How much copper is in there? Okay. Now, that is what the experiment will tell us. All of the copper that was here in this compound is now in copper oxide. If I had 10 coppers here, I now have 10 coppers over there. This is a known entity. It's dried. You can sample it. You can weigh it. Okay. So what we'll do for this thing is we'll use percent compositions to figure out how much copper is in here, and then therefore how much copper is here, and then for here. So what we do is here we say, okay, well, for this compound here of the copper oxide, what percentage mass copper is in copper oxide? And you can use your molar masses in your periodic table to calculate it, but it's around 79%. So whatever you got for a mass of your product, and you can, hopefully you're following along here as far as being able to calculate that this is 79% copper by mass. You say, well, if I have 10 grams of this, well then 7.9 grams of it is copper. All of that copper came from here and can be easily placed right here to figure out the mass percent copper of your unknown compound. So step one, again, verify my calculation, the percent copper in copper oxide. Then take your unknown sample and determine how much copper, how much Cu, how much copper is in your now known sample. From there, you'll be able to determine the mass of copper in your copper oxide, which, if you didn't lose any along the way, should be good to go as far as the mass of copper in here. Okay. Now, if you lose copper throughout your lab, this will throw off your lab. I mean, when you're transferring, when you're filtering, So be very careful that when you're doing things within your lab, not to lose any copper. This is the limiting reactant of your lab. So make sure if you add base, add plenty of base. Okay, when you're heating, don't lose any copper. For this lab, we will not be doing gravity filtration. We'll be doing what's called a suction filtration. And for that, you're going to want to learn how to use a Buchner funnel, and you're going to want to watch the video on a Buchner funnel. I will not be explaining that in class, but this is called gravity or gravimetric filtration. It has a lot of uses. Basically, we can figure out an unknown substance. For this particular lab, we are calculating the percent composition of copper in this compound. Then the actual identity of the chemical will be identified based on comparing this mass percent copper of this unknown compound to a list of possible knowns. Your lab has a list of possible knowns on there, so you'll just take this calculation when you add your two values, and then you compare it to a known list of possible unknowns. But we could do all sorts of analytical testing of water or various substances to determine unknown entities. Gravimetric analysis, we'll be doing another lab on this in the next section. So this is our run through, and then we'll be trying it again. But the way the lab sets up as well is we run this lab through with copper sulfate first. You know it's copper sulfate, you run it through, you test the values, see if it works, then run it through with an unknown compound. See how well it works.